we connected the motor to the PC, I mean EV3 to the PC, and we tested our motor. However, many cases you may see this dialog, something like 1 and 2. Whenever you see problems, especially when you have this question mark, I mean exclamation mark, if you click the exclamation mark, you will see this dialog all the time. You may try again, but there are problems. So even if the scratch link is running, you need to restart the scratch link. So I'll show you how how to restart scratch. So go to the taskbar and click this one. Then you will see scratch link icon. Right click scratch link icon. Then choose exit. That means terminate scratch link and restart scratch link. Then if you try again, then usually the problem is solved. For more information, especially for Mac users, use this link to set up EV3 robot to your PC. The first link is for connecting your EV3 to your EV3 software. This link is the YouTube video to connect EV3 when you use regular scratch, not ML4 keyed scratch, but quite similar to what we are doing. Okay, the next topic is we already had a break. Now let's continue project number 2. The project number 2 is text recognition to turn a Lego motor fan on off, and we tested something like that. And this is the code. I briefly introduce the code here on the screen, then I'll show you the scratch screen. Okay, so we start with this green flag that can be found under event. Then, because the system will keep asking you to enter the command, whether to turn on or off the fan. So we need forever loop, ask to enter, and the scratch stores your answer into the variable called answer, and use your answer to feed into the machine learning model, which will return either fan on or fan off, because the machine learning model has two groups. If the answer from the trained model is fan on, then execute next run, which is broadcast. This is something I need to explain. We may directly put the motor command there, but the current EV3 extension does not have to turn on the motor continuously. So that's why I had to introduce another for loop. You may ask, oh, it's okay to introduce forever loop inside here. No, in that case, you can't turn off. So that's the problem. That's why we are using the concept of multitasking. So it's like we have two independent tasks. So this task is being executed when I receive fan on message. So this task can be easily terminated. That's why I use this way. Also, I have another task when I receive fan off. If I receive fan off, I set the power 0. if I receive fan on, turn on message, then I set the power fully and keep turning on the motorway command. Okay? So here we have 3 scripts. When the machine learning model tells the entered text message is fan on, then broadcast fan on message. So it's like sending a message to this script, and this script receives the message and executes the blocks below, which means turning on the fan forever. When the text entered is belonging to fan off group, then else case broadcast fan off message. So the motor power becomes 0. So the motor will be turned off. Okay, so yeah, so now I'll show you my, okay, so this is the code and this is the model. So I want you to create first the project, then create 2 labels, one label for fan on, fan off. To add example, you can just enter plus sign, then enter please turn on. I don't have please turn on as an example before, so now I had turn on only, now please turn on there. For the turn off, I can add examples such as the same thing, you know, an example. Turn off, let's say please later. Yeah, so I have another example. So you can add all possible examples when people may ask to turn on the fan. Also, you know, examples of human text to turn off the fan. After doing that, I want you to click on Learn and Test. Now we have, I added 2 more examples. So I have 10 examples, 10 examples. No, examples are balanced. Then I can delete old model, then I can retrain here. So after the training, you can click on Make, choose Scratch 3, open Scratch 3, then you will get this. And we have 3 threads. Let's first stop all the programs. I don't need this anymore, so I can just I can throw away. To run it, always needs to check whether you see the green checkbox for the Lego EV3, which means the Bluetooth connection is set up. Then I can start from here to run. So I can say part here, and it will start. Then to turn off, code here. I didn't teach code here. Let's see whether this will work. Yeah, even if I didn't teach code here, it understood, you know, my request. Okay, so I'll give you some more minutes to complete this project. Especially if you are new to Scratch, I know it will take time to find the blocks. For example, forever is under control. This ask it's under sensing. So why sensing? So the computer systems keep sensing whether the user enters the the text keyboard data or not. So it's under sensing. This answer is a variable. So anything you enter will be stored in the variable called answer. And we pass this question from the user to the trained machine learning model. Then the model will return either fan on or fan off based on this logic. If the return value is fan on, it will broadcast fan on message. Then this script below will be executed to turn on the motor forever. Now, if you enter the command to turn off, then this trained model will return fan off, which means not true. So else condition will be executed. So it will broadcast fan off message. So this script receives the message, then make the motor power 0. So as you understand, we are not downloading any program to EV3 brains, EV3 computer's brain. So your laptop send Bluetooth command to operate your motors. Also, sensor data is sent to your PC through Bluetooth communication. So something like this cannot be used for overfast game, but exhibition style projects, it's fine to use this way, using the power of host computer, especially for image processing as well as speech recognition and text analysis and computer vision. Today, I don't have time to introduce real-time computer vision, but I plan another advanced ML EV3 workshop later. Also, I plan additional identical workshop on July 24th because, as you see, today's camp is full. So I plan another one on July 24th. I think I learned a lot today. I know what to improve for my instruction for the second one, but the contents will be the same. Okay, can you raise your Zoom hand if you completed this project too? Or you can say yes. Okay, so far 2 completed.
Yes.
3, okay. Okay, again, don't worry if you didn't complete this, because as you see, so many components are involved. Anything is not working, then the whole thing is not working. So yeah, I understand, the problem. So again, email me and text me, then I'll help you even after the camp. So actually, your questions, your content would be great to improve my curriculum, my slide, and my projects. But I did some Google search whether anyone did EV3 with machine learning using Scratch, but I didn't find any. So I think this is the world first workshop to learn about machine learning and EV3 with Scratch. As you know, there are so many social issues involved in machine learning, especially the face recognition technologies being introduced in many countries, and yeah, there are some issues. So as scientists, engineers, you need to first know what that is, how that kind of techniques, technologies are being developed, how we use, how we reuse, actually, the work done by others. So mostly for the face recognition, people are using deep learning, brain-based, machine learning techniques called DL, deep learning. It's very interesting. So many people trained artificial brains, then they allow trained machine learning model on the public so that anyone can reuse it. So the same thing, you train your model, and machine learning for kids has a function to share, your trained model. So it's like in the future of programming is searching for, machine learning models for your need. Even you don't need to retrain, you don't need to collect data. You just search for already trained machine learning models for your need, and you use programming language such as this Scratch. The only thing is to find, something like this block for your need, and just plugging in pre-trained machine learning model into your app, and you use it. And your app, but it requires the internet connection. Also, it's possible to download actually trained model so that you can use the trained model locally. So in the future, I believe a lot of changes in developing software. So currently we are looking for code code snippets on the web to find some sample code. In the future, we are looking. We will be, googling to find the right trained machine learning model to use for your need. So that's why I think this class is kind of futuristic, not ready, but in the near future, I believe in around 5 years, many people will be doing that kind of programming, that kind of coding. Okay, so since we don't have enough time, we have only 1 hour left, so I'll go to the next project. Okay, project number 3, sound recognition to turn a Lego motor fan on and off. So I'll first show a demo, and the project name is sound. We are handling sound data, and using the sound data, we try to turn on off the fan. So yeah, this is just a brief introduction. We need to record our voices, and we can see our recording visually in images like that. So for the sound projects, we need to also always record background sound. So we need 2 labels. One is for on, the other is for off. I'll be actually using only two English words, on and off. Oops. Sorry, my mouse is so sensitive. On and off. So you see on example, the pattern graphically seeing that way of my pronunciation. This is the graphical view of my pronunciation of off. So especially for sound recognition, yes, you need a lot of samples, a pronunciation by me or others, by female, by male, by young people, by old people. In that way, the trained model will be more accurate. Okay, this is the code, but I'll first demonstrate. So what I'll do would be I'll stop the old program and I'll show my sound project, and I showed you this. Yep, back recording of background noise, recording of on, recording of off. I'll demonstrate how to pronounce, how we record, but I want to show you first the demonstration. So click on make, click on Scratch 3, open in Scratch 3, and load, click on file, load from my computer, and sound on off fan, open. Okay, whenever you save and load, if it is connected to the EV3, then click on EV3, whether you see the green checkbox or orange exclamation mark. Oh, I see orange exclamation mark. So I click this, then I tested two EV3s, so I renamed one EV3 device as EV3A. So currently I'm using EV3A, so I connect this. Then it's connected, go to editor. So yeah, always check this green checkbox. Now ready to test. So yeah, this is the program that uses also, two independent scripts activated by the message. So I click this. If you see this, I am retraining. Train new machine learning model. I am retraining by using my code. Once training is done, so once one of my pronunciation is close to on, that's why my robot is reacting. Okay, anyway, so this code first train, then wait, because training takes some time. Wait until machine learning model training is ready to use. Then Scratch Cat says training has done. This message is displayed there. Then, activate the microphone, start to listen. Okay. Then I reconnect. I say on, off, on, off. So second off, it didn't recognize where. So I say again, because you see the problem why off is not where being recognized. I didn't record this sound as a background. So it's slightly different from the training data when I say off. So to make it work better, I'll move it far, but during my speech, some of my pronunciation was close to on, so it's on. So to off, I said off, then it stopped. On, off, off, off. Okay, it doesn't recognize my off there. Off, off, Oh yeah, finally it understood my off. So anyway, this is my program. So I want you to first start with this this training data. I think I just um, okay. I'll show you how we record the background noise. So I can add some additional example by clicking the plus button. Then you see the microphone icon. So to record, click on this icon. Then it will record the background noise. If you like this noise, record it. To add, then click on add. Now, number of samples for the background becomes 9. But this is quite different from previous data. See, the previous noise showed like there, evenly distributed, the blue dots, but something, is obvious. So perhaps it recorded my clicking sound or something else. So in this case, I don't like this sample. This is totally different from other samples, so I delete. So I'll add another one. Now it's more evenly distributed, so it looks like the real background noise. To add the sample for my pronunciation about on, okay, so click on this add example button, click on the microphone, but it requires a few seconds, so you need to say quickly. So click, then say. So I do that. On. Then this is the pattern of my pronunciation for on. And if you think this is similar to other pattern, then add it. I can do something else right after clicking this microphone on. Then you see, this pattern appears slightly on the left side. I'll add that. So those are the patterns of my pronunciation for the English word on. So the more, the better. You need to collect more to be more accurate. Regarding off, the same thing. Add example, click on this microphone icon, off, off. So I added two. So see, it's like two patterns, two things. The first part, the second part, off, off. But all the patterns are different. And we teach the machine learning model to understand similarities and differences between patterns for one label or one category. Okay? So after doing that, you need to train. So training for sound data takes slightly longer than numbers. So I can test it now here because I added some. So train, oh, so interesting. So if train takes long, then the system is asking questions. It's quiz time. So, okay, while you are waiting, oh, it's done now. But if you see the quiz time, yeah, please, answer some questions. You will learn more about machine learning techniques. Okay, now it's trained, and using this interface, you can test it, start listening. So I say on, off. Do you see? So this of 90% confidence. On, off, off. 99% confidence. On, on, off. So in that way, if you are satisfied with this result, then you can use it. If not, then you need to go back to verify, all the sample data looks okay. Also add additional samples. That's the step for you to do. Then after you have a satisfied trained model, click on make. Time to use the model for your need. Click on there, open Scratch 3, then you will get a program like that. So, okay, I'll just go through the program. I'll slightly make it bigger. Yeah, slightly
In
bigger.
the beginning of the program, you know how you train the model? Do you have to train it every time you run the program?
Thank you for your question. Yes. Uh, so if you try to use, machine learning techniques for, recognizing battles, raw fast battles, the condition, the lighting condition and your distance sensor may react differently. So it is recommended to use sensors to automatically collect data. So in project number 5, I'll show you how to collect data automatically, right? So I don't have time. I mean, this project is not for that, but please stay tuned for project number 5, how to collect data using your sensors. Okay, so before doing that, I need to talk more about this wait until block. Where can you find this under control? Wait until, repeat until is under control. So you can find wait until, repeat until there. This stay command is about showing, displaying, so it's under looks, stay. These black ones, dark ones, those are machine learning blocks. So click on our project name, sound on a fan, and you'll find here. Currently, we have a few blocks. They may need to add some more, but we have basic ones here. So after training by using your Scratch code, make the microphone activated to start listen. Then when the word on is heard, this script is activated, then this will send fan on message to this script, then this will turn on motor. I said on during my speech, that's why this is turned on. Then when I hear off, that means this machine learning system is invoking this script when the system hears off. It sends broadcast fan off message to this thread, this script, and this script is right after receiving fan off message. Motor A power is turned off. Then where can we find this broadcast message? Broadcast message is under events here. So click on broadcast. If you need to create new message name, click on new message, then type new message. I mean, any message name. You don't need to say new. I mean, MSG. You can say any name. Then new one would be one of the choices, for the message to broadcast, so that another script can receive this message and execute something. So script, another script, another script to actually operate the motor and to turn the fan on. I said off, on, off, so it works. Okay. Um, can you zoom raise if you completed this project number 3? Yes, 2 completed this. Yeah, I'll give you some more minutes to complete this. So this is amazing because if you create your code to do, for example, sound recognition by yourself, it will take at least 1 year to do projects like this, even if you are a professional programmer. But since we are reusing components developed by someone else, so and we can introduce those sound recognition using machine learning techniques in a few minutes. It's amazing. That means there are a lot of more opportunities to reuse existing technologies to create good applications for all of us. So someone may need to focus on details, but people are always willing to share what they have created. If you know how to find it, how to use reusable components in machine learning, then uh, you can create many interesting and useful applications, practical applications. So for example, like using Scratch coding language makes it much easier to create software, to create coding. Okay, so project number 4 and 5. Uh, project number 4 is about image processing. It's not video processing. It's about just still image processing. But I plan, video processing later because it takes because they are keep developing technologies. So I'll be incorporating into here, and it's slightly more complex. So I decided not to include today, and we don't have time anyway. So I plan another workshop, perhaps late August or early September, for the advanced machine learning techniques with ML4 kids. But as I mentioned, please first watch the ML4 kid video. You'll be amazed actually what you can do with that tool to learn the concept of artificial intelligence and machine learning technologies. So the video does not contain any project with the use of Lego robots. So I encourage you to watch some videos and some projects and try to connect EV3 robots to the project, then create videos, then upload. Then you have many followers, hopefully. Okay, now I think time to go to the next one. Project number 4, image recognition to turn a Lego motor clockwise or counterclockwise for 1 second. So yes, we are doing image recognition. So I decided 2 simple ones. Perhaps someone can create paper, rock, cedar game with Lego robots. So I have one group paper, another group rock. So this paper group shows my palm, and rock group is showing my fist. But as you see, every image is slightly different. Not the same. I didn't copy. I captured the image, one by one. So to create another image, yeah, I'll show you how to create. You can use the webcam to create. But this training will take more than 5 minutes. Then they are asking some quizzes. So if you train this, yes, try to answer the quizzes. Okay, so this is the program, simple program. So whenever my hand is shown, it turns the motor uh, left first, and whenever it recognizes my fist, it turns the other way. So that's the project number 4. So I'll demonstrate project number 4. So I'll leave this, and project number 4 is in another account. So this is in my second account. I go there, go to my project. This one has image paper rock left right to turn motors. So click this, click on this. I have 16 images to represent paper, and I have 16 images to represent my fist or rock. How do you add? Yes, click on webcam. Oh, because I think I can disable my. Okay, then I can go there again to use my webcam. Then yes. So actually, I realized I'm wearing different shirts. My background color is different. Now I show my palm. Okay, so this example is slightly different. So I took those pictures last night. The background color is dark, this brighter, and I'm wearing different color t-shirts. So I can add another one. Those are sample images to represent paper. Okay, let's add another one for rock. So I'll add this. I'll add another one like that. Now I have 18, 18. So go back to there. Also, I'll enable my camera. Yep. Then, in order to retrain, I need to click on, I need to delete the current model and retrain. But I will not do that because it will take quite long, more than 5 minutes. So I cannot do that. But that's the way to train. Because it takes long, you will be asked some quiz questions. So now let's just use the test. Scratch number 3, opening Scratch 3. Yeah, then let's load my previous program, image paper rock. Okay, again, since this is using motor, let's check whether the connection is okay. Oh, it's interesting. Oh, I cannot do this. Okay, yeah. Yeah, the connection is lost, so I need to click on this, select my EV3, and go to editor. Now, this is the program. I just run it, and you will see how this is working. So it recognizes different, you know, images, and the motor is acting accordingly. Clockwise or counterclockwise. In order to implement that, this Lego EV3 has user-friendly method called turn current way, and if you execute this one, turn the other way. And it keeps repeating. But I need to tell you something. So images were already stored. So that's why I'm saying this is not using real-time video. So next time I'll tell you how we can do the real-time video processing, but it's kind of slow. But certainly we can learn about the concepts of, like face recognition, human detection, something like that, and you can connect Lego robot what to do, what to actually react physically. Okay, so I'll just explain about this new code. So start with, yeah, I'll disconnect because it's too noisy. Okay, so infinite loop. Inside we have one if else, decision making block. If the trained model to recognize images between rock and paper, whenever so this costume image is like giving the input image to the trained machine learning model. Then the machine learning model will return either paper or rock. So here, if you want to change this to rock, then we need to change these actions. Okay. But you see where we can find this cost image. Cost image can be found under images. So yeah, so there are other blocks to actually store some camera images automatically, but we are just using this cost image into here. Okay, then if this is rock, turn the motor counterclockwise. And otherwise, that means, because we have only two choices, so otherwise that means the machine recognizes the image as the paper, then turn the motor clockwise. Okay, so that's the program, but I know you can't do this here today because it will take a lot of time to train and collect images. So this is kind of your homework assignment. If you complete this, yeah, please let me know by email, and I'll show you some other things for you to do. Okay, so I think you have basic information to recreate this project number 4. And I know you cannot do this, so I will skip the work time, and let's go back to our slide to continue. Okay, now project number 5. Yeah, this is more practical project to use 2 different sensors. You need to recognize numbers from 2 different sensors to make a decision to turn on Lego motor only when light sensor detects dark and distance sensor detects an object. So it's like, turn on the light only when someone is in the room. That kind of logic, to use trained models. So, this project also focuses on how to collect data automatically, because, robots will be placed in different environment. Light condition is different, object size is different, many things are different. Also, sensors are all different. The numbers you get will be different from one system to another system. That's why we need to collect data dynamically, not statically. So far, project 1, 2, 3, 4, we collected data manually. That means, it was static. Project number 5, collecting numbers, collecting example data dynamically, especially for robots, and train them on the fly. How we can do that? That's the main purpose of the project number 5. And this is practical project for robotics applications. Okay, so let's go. So as I mentioned, you need to analyze the conditions to do this. So we have two sensors, light sensor, distance sensor. When light sensor detects dark and something is near to the distance sensor, the action is turn on the light. Light sensor detects, oh, it's dark outside, but no one is there. Distance sensor is detecting no object near. Then don't turn on the light. Don't waste the energy. So turn off the light. Light sensor detects bright. Don't need to actually turn on the light, even if someone is near to the distance sensor. That means someone is in the room, and the room light is bright. The window, it shows a lot of daylight. Then don't turn on the light. The action is to be turn off the light. Uh, the room is bright. No one is there. Don't need to turn on the light. So, but to simulate the dark condition, what I did was just cover the light sensor with my finger. To simulate the far, I just pointed the distance sensor to the ceiling. Okay, that's what I did. Okay, in this case, slightly complex. For the turn on class, turn on label, you need two numbers for each example. So I covered the light sensor completely, then the value was 0. Distance sensor, the distance sensor was pointing to my monitor, so the distance was around 12 inches. Light sensor 1, still very dark. Distance sensor, I move my hand. So those are conditions for turning on the light. This is the condition to turn off the light. Dark, but no one is in the room. That's the first case. This is dark. So number 6 is like, quite bright condition because I tested last night. My room was kind of dark. So the room is bright, but that means someone is close. No need to turn on the lamp. The last case, room was bright, no one was in the room. Don't need to turn on. That means those are the conditions for turn off. And this is the program to how to collect data automatically. And so we have 4 cases. I collected this separate. So this is the case for the number 1 case, number 2 case, number 3 case, number 4 case. After collecting data, here, I use machine learning block to train, and I notified by typing train has done on the cat so that I know training is done. Then introduce endless loop, uh, you know, to make decision whether to turn on or turn off the light. So that's the code. So I'll first demonstrate. Okay, I leave the previous program and I go to project. The project name is num2 on off light because we are using two numbers, one for distance sensor, the other for the light sensor to turn on off the light. So if I go to train to see, yes, you see those. Actually, those numbers were collected automatically. If you want to, add example manually, yes, you can do that too. In that case, you just enter license value as 2 to still quite dark, and distance sensor you can enter like 13. It's fine. You can add. The same you can add some. So that means you need to analyze sample data. Analyze sample data. If you feel you didn't collect completely well through the automatic program, you may add. Also, if you use automation, sometimes some noise data can be entered, then you can delete it too. To delete, you can use just hover around your mouse, then click the X, then you can delete it. Okay, after the to train, you can use this. Also, you can use your program, but as I mentioned, you have to, we'll be using the program to collect and to train. So how we do that? Uh, so I go open and load from your computer, and I'll select num2 on off light. That's the pre-written code. Okay, so something new. So in Scratch, under event, the shape like this, oval shape, up oval shape, that means that's the start of your script. So you may select when something has pressed. So default one is space. So if you use this, and if you press space, so like, let's test. And I type space, then you will hear that cat sound. Okay, so I chose when number one is pressed because that's the number one case in the table I do. So to select the key, you can down there and you select one. Then whenever you press one, the following blocks will be executed. The same thing, number two, the following. So, okay, so I'll press number one, then, but you have to understand, how what kind of data you will get if you press one. This program is first displaying get data for turn on when dark and near. That means light sensor should be dark and this distance sensor should be something near. So it's like, as I mentioned, I cover my color sensor with my finger and I put something close object like this box. So that's the condition before before you press one, so that you can collect new data. So I'll do that, but before doing that, this requires the connection between the robot and your PC. So let's check the connection. Oops, as you see here, it's not connected, so I need to connect first before collecting. Okay, so now I covered with my finger and I put something close. Then I type 1. Then you will see, this script has glowing edge. So I type this glowing edge, gathering information, and no more glowing edge. That means the data has been collected. Let's see whether the data has been collected by going to ML4 Kit. Yes, in the beginning we had only 10. Now we have 20. That means those data were just collected. 10 new data was just collected automatically. The same thing for turn off. You have to follow, the conditions. How before you press number 3, you need to make sure the light sensor sees bright and distance sensor sees something near. Then collect data. Number 4, bright and far. That means, just point to your robot to the ceiling. So that's number 4 condition. Then press 4, then you will collect data for this condition. Okay. So then now time to introduce the code. So let's say we collected all the data needed. Oh, by the way, one comment. So someone says, oh, this group has only 10 data. This group has, more than 10, like 30 in the beginning. It's not well balanced, but based on each case, it's balanced. The sample data has, exact same number of, cases for each case. However, still, we may need to add some more data for turn on. It had 30, it had only 10. That's why I added another one. So 20, 30, that would be okay. Now, after collecting data for all 4 cases, case 1, case 2, case 3, case 4, then this is the main program which will be executed when you click the green button. The first block is to train your machine learning model. Because it takes time, let this cat display some message. Then we have endless loop. Inside here, this is calling the machine learning block to recognize numbers from light sensor as well as distance sensor. So you can find those 2 variables from here. If this is clicked, you will see actual values over there. So get 2 numbers, feed to the system, train the model, then the model will tell the answer, whether to turn on or off. If the output from the trained model was turned on, then we need to switch backdrop to yellow. Then just for sound purpose, I turned motor A. So, okay, let's test this program. Okay, so I first test the case number 4. This is facing up. That means the room is bright. No one is here, so don't need to turn on the light. this is the case. Room is bright, but someone is here. So I put my hand near to my distance sensor. Don't need to turn on the light. Now I simulate the room is dark by covering the sensor with my finger, and someone is here. So the background color becomes yellow, and you are hearing the motor sound. Okay? Now the room becomes bright, and the motor stopped. So, okay, so this is the logic using the machine learning for slightly complex problem with two sensor data. And this program communicates with the motor. Okay, so yeah, I know you don't have time to recreate right now, but that's
Question.
your,
Oh, sorry.
your assignment. Yes, question.
Do we get to keep our accounts?
What
Like
kind
our
of
account,
count?
like the machine learning for kids accounts.
Oh, okay. So the current account has some limits. I don't remember all the details, but you can keep 3 projects. I think the duration is uh, unlimited. So as long as I don't delete your account, you can keep your models on your account. Also, they limit number of sample images, number of sample sound files. But I know you have unlimited of number data to use. So for details, visit the site, then you'll find all the detailed numbers. Any other questions? Okay, now I have an assignment for you. Okay, the first assignment is test all the projects 1, 2, 3, 4, 5. And if you have troubles, please contact me. But the assignment is this: create any new project using the ML techniques you have learned today. So I said new project. So slight modification is fine, not exactly same. You can just modify something and send me your video link with your Scratch file by July 12th noon. Then selected teams will win prizes. At this time, I promise to ship you to your address. Okay? So do something during this weekend. Send me the video together with the Scratch file. Also, I'll check because I know your password, so I can access your account. So I'll check your model in your account, and I see your video, and I check your Scratch coding. Then I decide some teams to win. Then you will get prizes, surprise prizes. I am thinking, I know, so we have many international users right now. So I plan to use, Amazon account. I heard, I can ship something directly to international address through Amazon. So I'll test that for the first time. So yeah, you will get something good if you do this assignment. Any questions about this? Anyone is interested?
I am.
Okay, thank you. Yeah, at least one. Yeah, please do something. You'll get something by mail. Okay, yeah, 2 people are interested in this assignment. Please do it. Yeah. Again, don't need to create complex project. Just do something, like adding additional sensors, do something. Then you'll get a prize by mail. Okay, now time to get some feedback from you. So this is the post survey for you. You may reuse my slide files for your instruction anywhere around the world, but please give me a credit. Okay, as long as you give me the credit, you can freely use, this slide and sample programs. Thank you, everyone. See you next time when we have the next level course. Goodbye.
Bye. Thank you.
Bye.
Bye. Thank you.
Bye.
Bye
Thank
bye.
you.
Thank you. Thank you for joining.
Bye.
Stay safe and keep learning.
All right.
Next time.
Hello, Professor.
Hey, Jackie, you're still there. Yeah.
Yeah, I would like to ask a question. For the images, if we can capture each image by webcam, right?
Yeah. Actually, I realized I didn't cover that part. So,
Yeah, and
so
how
I'll show you
about
how to capture. Yeah, I'll show you how to capture right now. Oh, I forgot that.
yeah.
Yeah.
How about if we want to import a lot of image at one time?
Oh, sure.
Not
Yeah, you
one
can do that
time.
too. Yeah. You can.
Can we do it?
Yeah. So I'll show it. I'll show it to you right now. Oh, I forgot to show that on. Yeah. Okay. So I'll show you what I did. So here on the project, we have images like this. Those are
Yeah.
for training. But we need test images to test the program. So what I did was, okay, so I changed the sprite. You don't see any cat anymore. I changed sprite name as my own sprite, paper or rock. Then click the sprite. Then click costumes. Okay, click costumes over there. Okay, actually I like to make sure this is still recording, so I'll edit this. So after seeing those, you can add something new image. So you can get it from camera. So I click camera. Oh, but currently camera is being used, so I cannot get it. So what I need to do is I need to disable my video because I have only one camera. In the future, I may need to have two cameras. So again, currently I collected 1, 2, 3, 4, 5 images, either this paper or rock. If I want to add some more, click on this. First click on this cat plus, then click on camera.
How about can we go back to the training mode?
Oh, okay, just wait. Oh, I don't know. It's not conflicting with anything. Okay, so you mean here?
Yeah, here.
Whether
Okay.
you can add? Yeah, sure. So
As
it's
here
very
we
interesting.
can add one by one, but how about
So
can
yeah,
we
I'll show you
import
something.
Okay.
Actually, you can just drag and drop any pictures. So I'll show you one thing. Let's say I have some pictures, any pictures like this one. I can actually drag and drop. I can drag and drop. Then that was added. That was, oops. Oh, okay. So I got on the warning. You can't upload pictures from your computer. The file was on my computer, so you cannot drag and drop. The pictures that already must be online.
Okay.
So I need to find a picture online. So
Okay, got it.
yeah. Did you do that? That's great. So I go to I go to RoboFest. Then I put this picture from the web. Just drag and drop. That means you can find a lot of pictures, online. Then you can use those pictures to train your model.
Yeah, it's important because you
Yeah, that's
cannot
important.
take all the
Also, you
photos
can
by yourself.
add something. You can draw. Anything you can draw can be added there too.
Mm,
So this is great project for young kids actually. Like
yeah,
recognition of handwritten, characters, something like that. So it's so fun actually to create a lot of interesting classes for people, for young
okay,
people.
got it.
You know,
Thank you so much.
this is what I learned.
Yeah,
Children are amazing. They are observing, you know, uh, new things very quickly. For some others, even if we see, it's hard to follow the exact step. But young people, even if they didn't see, they know how to figure it out to use computer tools, computer interface by themselves quite easily. So that's why the classes like this would be quite good for young children actually. So especially like recognition
yeah,
of
I
drawing.
agree with it. Yeah,
Yeah, yeah. So
thank you
that's
so
one
much.
thing, but I didn't complete this part.
Mm-hmm.
So we can, let's try once more using camera. Uh, yeah, something wrong with my camera. Can't, I can't. But here you can upload any file. You can
Mm-hmm.
draw. Even you can draw. Uh, you can draw like this. Then you have that one, as one of the costume in the sprite named Paper Rock. Now
Mm.
let's see how we use. So, okay, so costume image means the current costume. The current costume is the handwritten end.
Mm.
So based on that, I'm curious whether this is recognized as, you know, okay. I disconnected the sound. I'll add new sound here. And let's see whether my handwritten drawing is recognized as paper or not. I'm curious. If you hear new, then it is. No, no, it was not recognized. Handwritten, I didn't hear new, so it was not recognized. It's totally different from background, everything is different. So anyway, that's the way to program, but so get the first image defined in here in costume, feed it to the machine learning model. If that's paper, then do this. If not, do that. Then get next costume, next graphic, next image file. Then do the same thing repeatedly.